Alright guys, quick video on Newton's second law of motion. Newton's second law of motion is really just a formula, but it essentially says that the acceleration of an object depends upon the mass of that object as well as the force that's applied to it. And then after the force is applied to an object, the object moves in the direction that the force is applied. We calculate this using this formula. Force, which we measure in newtons, is equal to mass in kilograms times acceleration in meters per second squared, or F equals ma is the way we will typically just kind of say that quickly. So we can look at this triangle method to work through this problem, and when we put this formula F equals ma into a triangle, force in newtons goes up at the top with mass in kilograms at the bottom and acceleration in meters per second squared in the other bottom slot. It's important to know that, or recognize that this means that 1 newton is equal to 1 kilogram times 1 meter per second squared. That's what a newton is equal to. So there's a couple of problems on the right hand column of your notes page. If you can give it a try, you can pause the video for a minute or two, give it a try. There's like 3 problems for you to try out, and then we'll come back with the setup and answer for these problems. Alright, now that you've tried those 3 problems, here is the setup and answer for those problems in order. So the first problem results in 68.6 newtons forward. When we provide force, it is important that we give a direction. So even though you weren't given a direction in the problem, forward is kind of a good default direction to lay to. For question number 2, 40 meters per second squared forward, or 40 meters per second forward, would be the appropriate answer. And finally, the mass for the answer for question number 3 is 8.5 kilograms. Now there's a little demonstration box for you here, and obviously if we're doing this by video, I don't have a demonstration to give you, but you should be able to kind of think through this. If I was to supply a force, or if you were to supply a force, a push on a single book, will that accelerate more quickly than if you pushed a stack of 5 or 6 or 10 books with the same amount of force? Which do you think is going to accelerate more quickly? And the obvious answer to that is that a single book with less mass would accelerate more quickly given the same force applied. So if you need, you can give that a try with some materials that you have at home, but as the mass of objects increases, the same amount of force is going to supply lesser acceleration. The other way to look at it is if mass of an object increases, it requires more force applied in order to maintain the same acceleration. It's kind of a different way to look at that. Alright guys, there's your quick video on Newton's second law of motion.